Welcome to Equine Digestion and Physiology Part 5. Digestion and absorption. Both processes are necessary. You cannot have one without the other. You can't absorb feed if it's not digested, and it's no use digesting it if you're not going to absorb it. Digestion is the process of breaking down the complex nutrients in feed into simple molecules through physical and chemical digestion. Absorption is the transport of small molecules across the intestinal wall into the body via a passive or active transport system or through receptors. More specifically, absorption is the movement of products of digestion across the intestinal epithelial lining, or the wall of the intestine, into the vascular system, or the blood. Usually molecules will move across a cell membrane barrier in response to a chemical or electrical gradient. In other words, if you have a high concentration of a certain chemical on one side of the membrane and a low concentration on the other, the molecules will move across from the highest concentration to the lowest concentration. The same occurs with an opposite electrical charge. Positive is attracted to negative and negative attracted to positive, moving the molecule across the membrane wall. When your horse eats, its intestines normally hold a higher concentration of nutrients than the blood, so these nutrients easily flow across from the intestines into the blood, a passive transport system. Many times though, these nutrients are too big in size or have the wrong electrical charge to just pass across through an electrical or chemical gradient transport system. What you need then is an active transport system. So a passive transport system is where the charged ions pass freely through the cells that make up the intestinal epithelial lining, with the only regulatory control being the cell's ability to open and close these channels, usually in response to different nutrient concentrations or electrical charges. An alternative method is the active transport system, where nutrients are actively transported across the gut wall. Something has to take hold of that nutrient, pass it through the cells that make up the wall membranes, and release it into the blood. As there is a lot more involved, it is an energy-expensive process. So to recap, the passive transport system really is just having a charged ion on one side of the wall and more oppositely charged ions on the other side of the wall, or a higher concentration on one side and a lower concentration on the other. The nutrients slip straight through. This allows free movement of things like water and electrolytes such as sodium, potassium, chloride, and bicarbonate. The active transport system is for much larger molecules or where there is less of the nutrient in the intestines than the blood, but the body needs the nutrient. This system allows the nutrients to pass through the cell walls into the body via what's called the sodium-potassium ATPase pump. Sodium is pumped out of the cells and the potassium pumped in, against their concentration gradients. In other words, moving the nutrient from a low concentration to a high concentration instead of the other way around, as in a passive transport system. For example, the sodium-potassium ATPase pump pumps more sodium into the body from the digestive tract, even though there is a higher concentration of sodium in the blood than in the digestive tract. This same system also transports other nutrients with the sodium from the digestive tract into the body, like glucose, which is sugar, and amino acids. Another way for the body to absorb nutrients from the intestines is through receptors. You can have specific receptors on the outside of cells, and they will take hold of specific nutrients, particularly things like amino acids, and transfer them across the gut wall. These receptors will bind these specific molecules and allow them to pass into the cells of the intestinal wall, where they will be modified before passing into the body. Some receptors have shared sites. In other words, two or more molecules can use them. And this is important when we talk about mineral and vitamin antagonisms. An antagonism is something that reduces the absorbance of a mineral or vitamin due to its presence. So the more of one thing, the less something else is going to be absorbed. When a shared receptor, which allows just one molecule through at a time but can capture more than one nutrient, is exposed to an oversupply of certain nutrients, the oversupplied nutrient will flood the digestive system, taking up a lot of these multiple binding sites. This is very common in horse diets, for example, when there's too much calcium and phosphorus. Another commonly oversupplied element is iron, which does the same sort of thing, taking up many of the shared receptor binding sites. This results in other key minerals or vitamins not able to be absorbed. In the end, a mineral or vitamin deficiency can occur through an oversupply of some of these other overabundant minerals and vitamins blocking the shared receptor sites. This is why it is important that nutrients are supplied in the correct amounts in your horse's feed. Today, our key take-home points for this YouTube clip are: absorption is the transport of small molecules across the intestinal wall. Passive transport moves nutrients across a cell membrane in response to an electrical or chemical gradient. Active transport moves ions or molecules across the membranes against either an electrical or chemical gradient. Receptors will bind to specific nutrients and move them across the cell membrane. And some receptors have shared sites and can cause vitamin and mineral deficiencies if not provided in a balanced diet. Thank you for watching Equine Digestion and Physiology Part 5. This concludes our first series. If you like what you saw, please give us the thumbs up and share it with your friends. Connect to our website, our EQNC Facebook page, and our Instagram so as not to miss our next series.